So here are some facts about neurons. There are a lot of them, about 1,000 billion of them, and each neuron can be connected to around thousands, perhaps tens of thousands, other neurons. So it's an extraordinarily complicated computing device. Neurons come in three flavors. There are sensory neurons, which take information from the world. So as you see me, for instance, there are neurons firing from your retina, sending signals to your brain. There are motor neurons. If you decide to raise your hand, those are motor neurons telling the muscles what to do. And there are interneurons, which connect the two. And basically, the interneurons do the thinking. They make the connection between sensation and action. It used to be believed, and it's the sort of thing when I taught this course many years ago, I would lecture on, that neurons do not grow back once you lose them. You never get them back. This is actually not true. There are parts of the brain in which neurons can regrow. One interesting thing about neurons is a neuron is like a gun. It either fires or it doesn't. It's all or nothing. If you squeeze the trigger of a gun really hard and really fast, it doesn't fire any faster or harder than if you just squeezed it gently. Now this seems to be strange. How could neurons be all or nothing when sensation is very graded? If somebody next to you pushed on your hand, the degree of pushing, you'd be able to notice it. It's not either pushing or not pushing. You can degrees of pushing, degrees of heat, degrees of brightness. And the answer is, although neurons are all or nothing, there are ways to code intensity. So one simple way to code intensity is the number of neurons firing. The more neurons, the more intent. Another way to increase intensity is the frequency of firing. So I'll just use those two. The first one is the number of neurons firing. The second one is the frequency of firing. In that something is more intense if it's bang, 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 than bang, bang, bang. And these are two ways through which neurons encode intensity.